Problem sheet 4, question 3. Use Monte Carlo simulation to find the probability P that when 4 dice are thrown simultaneously, they can be split into 2 pairs with equal sums. For example, the roll 3, 1, 3, 5 can be split into 2 pairs with equal sums because 3 plus 3 is equal to 1 plus 5. However, 2, 2, 2, 4 cannot. Give a confidence interval for your estimate. So we will use the random library to generate some random numbers. And we will define a random experiment as rolling 6 die together. And we will consider a success if they can be split as shown, and a failure if not. First, let's define some useful functions. So one useful function would be rolling a die. This uses the randint function of the random library to choose a random integer from 1 to 6. So for example, every time I run this, I will get a random integer between 1 and 6. Now it would be useful to be able to have a function that will perform the check for us to see if 4 numbers can be split so that they can be split into 2 pairs of equal sum. So this function will take in 4 arguments, which will be the 4 numbers or the 4 dice rolls. Let's say A, B, C and D. Now out of 4 dice rolls there are 3 combinations. So combination 1 would be that A plus B is equal to C plus D. Combination 2 would be that A plus C is equal to B plus D, and combination 3 would be that A plus D is equal to B plus C. And there are no more combinations of splits. So if any of these combinations result in a split so that one side, the sum of one side is equal to the other, then we have a success. We can use this and check. So for example, let's check the 2 examples from the question. So we can see that 3, 1, 3, 5 is successful as required. And 2, 2, 2, 4 is unsuccessful as required. Now let us use these 2 in order to perform many random experiments. So let's set the seed and decide how many trials we are going to perform of this experiment to gain an estimate of this probability. Let's say 1,000 trials, and let's keep track of how many successes. So far that's 0. Now for every trial in range n, we can roll our 4 die. So A, B, C and D would be the result of a roll each. We can perform our check, and if that is successful, we will add 1 to our count of successes. Then our estimate for the probability, P, is the proportion of successes over the trials. With 1,000 trials, we get an estimated proportion of 0.254. Now the question does ask to give a confidence interval. By default, let's choose the 95% confidence interval. So our lower estimate for this probability will be P minus 1.96 and our upper estimate and so our confidence interval, our 95% confidence interval, will be our lower estimate to our upper estimate, which in this case is 0.227 to 0.281.